Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Expansive Subgrade Problems and Remediation. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures and to elders past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's long-standing industry partner, Geofabrics. Geofabrics is Australasia's geosynthesis specialist. They help their clients deliver and maintain infrastructure by minimising risk and increasing value through the innovative use of geosynthetic products. Geofabrics have supported the Australasian infrastructure sector on significant projects from the Victorian level crossing removal to APLNG in Queensland and the Christchurch gondola in New Zealand. On these projects and every project they undertake, they have a singular focus to provide smart infrastructure solutions. Today, we will hear from two speakers, followed by our live audience Q&A, and I encourage you to send questions through to our speakers via the YouTube chat box. I'd now like to welcome our first speaker, John Lee. John is the leader of WSP's New South Wales Pavement Design Group, with 26 years of experience in international construction projects, and is a pavement specialist in the design and construction supervision of both highway pavement and heavy-duty pavement for Australian Defence Force, ports and industrial applications. John's concrete and flexible highway pavement design experience has been founded through a diverse range of infrastructure projects, the majority being for Transport for New South Wales highway projects. Please welcome John Lee.
Thank you, Amanda. Thanks for the introductions. And it's an opportunity for me to speak to you today in the expansion of subgrade problems and remediations. I'm John Lee, the Principal Pavement Engineer from WSP. And for today, I'm going to go through this with you. This is my roadmap today. First, on knowledge of the countries. The next one is the pavement design approach to tackle those soft and expensive subgrade. And the third one is actually what is the impact on pavement for expensive subgrade, because this is on the practical side. And I'm sure my colleague Albert will have a very details of the way how on the theoretical side how to do a design solutions and all those on that part. So that's why on the theoretical part I keep that one in Albert's good hand. So for me, I will guide you around for four aspects. Those four aspects are because I'm in New South Wales, Sydney, and the road state authorities is Transport New South Wales. So first two is to go through how Transport New South Wales is going to tackle the subgrade issues on a new road, greenfield. And the next one is for the maintenance side, rehabilitations for those the brownfields, how we are going to do it. The next one for another one is, say, for example, for the private developments or the councils, we also have the design approach methodologies to the council payment profile as well. And for the last one, just give you a sort of like overhead or have a look in heavy industrial or port situations, how we're going to tackle it. And to wrap up, as in my conclusions on my part, I'll show you the myriad of synergies. When we work together hand in hand, is 1 + 1 = 3. Okay, so first we're going to start with the knowledge of our country. We'd like to acknowledge the GACA of the United Nations, the traditional custodians of this land, and pay our respect to the elders, both past and present. This is the paintings I keep for putting out Yeah, 15 years plus already. It's like in my house. So for next one, this is the one for me. I've been working on payment design for 2 decades, and whenever I'm going to tackle those source of it also, this is my hit list. The first one is I need to understand situations for the projects, the end user going to be a road, port, or is a maintenance job, and the stakeholders involved. Like just then, I'm talking about those one road authorities, council, or asset owner as well. Then I'm learning or getting the informations from local, interstate, and international as well. So, because the key is I need to give out practical solutions, and apart from that, from paving the road, I need to get help from other disciplines as well, like geotech, the major one, needing their help a lot. Road designer, drainage designer, utilities, and structure as well. And for the output, I'm focusing to give an output which is fit into a whole of life effectiveness, which is not just a design, because like it's not just a drawings or report calculations I'm giving out. I need to give out a payment profile which is working through the design stage, and for the contractors, I need to give that advice and support for them during the construction phase services, as long as same as the asset management as well. Then lastly is the fit to purpose. We'll come back again for that fit to purpose in the end as well. So for the first, this is the one which is in the job, say the payment services we're providing. Yep, similar to the last one. And for us, for what I see, the major issue with soft subgrade, expensive subgrade, is that subgrade failure. When the subgrade fail, we lost the support of the pavement. And once it lost the support, we cause the safety issues, and it can cause life or injury. It's a serious impact on those. And like for that part, it's our responsibilities to provide a safe, not just a safe design, safe output as well. And the next thing is, even the pavement is still functioning with a source of raise also, we need to have a very frequent maintenance. So if we have the maintenance activities in a very frequent status, which means we add on the cost. Just like in the first line I showed as well, whole of life is a very important aspect. Whole of life is not just design construction, maintenance is a key part as well. So the thing is, in overall, for our output, we need to make sure we have functional deliverables and effectively cost. So right now, allow me to share with us some of the photos of a filter proof road, because this one been through the proof road already, and this happens in last year when we have over 200 days of rain in New South Wales. So we try our best, and we try to drive the subgrade, make sure of the things as we can as well. And we still come with an issue to say, after we do the compactions, proof and stuff, it still looks like this. And more photos of that as well. So for us, we're not taking chances. For a situation like this, there's two approaches as well. First, we don't have the luxuries during the rainy days to wait for it dry, because it delayed the construction process as well. And on the same time, we need to have a good quality control, just like my colleagues say as well. One farm thing on a first approval is a huge road of improvements in a software medium world. For us, we need to get the things right. And just for the next step, allow me to show some of the examples for you. First one, just like what I mentioned before as well, when I do a new road for Transport New South Wales, this is the design approach, and I'm going to give out So for, yes, of course, I need to work together with Geotech and study the bore log, the CBR lab test as well. And the key is when we found those soft area, we need to compile it with Oslo Guide to Pavement Technologies Part 2, also the supplements, transport supplements to the Part 2 as well. Then we're going to apply just for the layer, called as control subgrade layers over there. And whether or not we're doing the in-situ stabilizations, maybe lime or cement, we determine case by case as well with the project requirements also. And the key point is, on top of the stabilized layer, in here we have 300 mil, we also need to put the tensile TriX TX100s or equivalents on the subgrade, original subgrade. Yes, and put this way, I will discuss further later on, but at least do bear in mind we have a few choices over here. First thing is 1 or 2 layer of the geobrick, where you're going to put the geobrick as well on 2 layer, and in between those in-situ stabilized materials, whether or not we have the choice to do lime or cement. We'll do further in Q&A also. And for the next one, this is for the boundary. So for the maintenance work, we might not have the luxuries like the greenfield, just let me see, or 1 meters and all those. So for greenfield or contaminated areas, we might have a very limited area and excavation depth to do it. And the key thing is in China, New South Wales, we'll have a very good guide over there. Will be Transport New South Wales M209, road opening and restorations. And the key things for maintenance work or rehabilitation is on top of the geobrick, we need to make sure the subbase or the materials we put back is synthetic. And the key for that is when we do those are self-compacted, and we have less disturbance to the original ground. Because think about this, for example, for this line, you having services over there. It can be existing services, or even if it's not existing services, we might not have the luxuries to say that gas pipe is 1 meters, or for the other services 600 more. So we need to work together with utilities, drainage, road designers to file integrated design. Yes. And for the next one, this one is for council job, and this profile is being delivered during the times of the heaviest rain for approximately the 200 days or so. So just as I mentioned, we don't have the luxuries to wait for it to dry and for those. So we are keeping that balance to say that we're looking for 2 layers of the geobrick and with that cement stabilization as well. So it's massive, and the key is in the end, we are able to get these pavements constructed. And that's the reasons I'm doing the lesson with the asphalt and the stabilized material. Because for us in that situations, I would say this is an appropriate design approach as well. And one tip as well, I mentioned in the conclusion as well, when we do a proof flow also, don't put the geobrick and do the proof flow. You just waste your effort and waste the money, because after the proof loading and stuff, will ruin the geobrick. And this is the one I'm just going to touch briefly. For this one, this is for the port for what we have done as well. And make sure we put that geobrick and the stabilized materials on the subgrade level as well. Because the key is, especially for heavy loadings, we need those. It's not in the same mode or like road is 8 tons doing the direction, we can expect 4 tons. It's for all the direction as well. So we need to make sure we have a safe design for that approach. And most importantly, for all the design, one of the key things for all the design is we need to make sure there are sufficient subsurface drainage system because to get the waters out from the pavement layer to make sure they have less chance to be saturated. This is our key role because the key is make sure, because once it gets saturated, it fail and they lose upstream, they will come with a subsequent lock-on impact. Okay, thanks for that so far. And this is the one I'm going to share with you. We can talk more on Q&A as well. First things, for those stabilization work, geogrid work, it's not a strict design approach or the deliverables to minimize the excavation depth. So in a greenfield or based on the project requirement as well, it's not the way to say, oh, I want to have less earthwork or so, unless we have a very good reason, like my next one as well. If the area is contaminated or there are utilities, we need to consider, we can't put it this way, just a cost saving look is not strong reasons to get into those less excavations depth. Okay, and for as a designer, because I'm a designer, for my standing point is I need to design fit to purpose and meet the requirements of the design standard specifications and project requirements. And in here, I borrow the ideas from rail, the SFARP. For my deliverables, I have to ensure to be so far as reasonable practical. Because like the case is when, just like I mentioned before, when I have a good drawings, anything, then if the contractors can't construct, I'm causing troubles instead of being a problem solver. So we need to bear this in mind. And in simple terms for this one, for our output, we have had to be fit to purpose. So the last part of mine is like this is what we need to bear in mind as well. So construction abilities, because no man is an island, and for us, we ought to work hand in hand. When we did fabric design also, have to be practical. Yes, I say this many times already because like all those things we go on, we need to deliver actual structures also lasting for the design line. So we need to make sure the things are constructible, be there, durable as well. So this is the next key point as well for fit purpose. We will talk more in Q&A of the lime stabilizations or the cement stabilizations. Then the second last one is the choice of 1 or 2 layer of geogrid. And the last part, if we choose 2 layer of geogrid, make sure there are 300 the stabilized materials in between as well. Because those are the things when we need to do the works, we need to do good works. And the last of the things that we take away, we make sure the pavements, subgrades, have less chance to be saturated. Whenever we can, we get the water out. That's the key points for us today. And thanks for that. And I look forward to answer more questions during the Q&A. Thank you.
Thank you, John, for a great presentation. I'd now like to welcome our second and final speaker, Abid Ali. Abid is a Senior Applications Engineer for Geotechnics at Geofabrics Australasia and is responsible for managing technical queries related to the use of geosynthetics for a variety of civil engineering applications such as roads, railways, mining, waste and containment. Abid regularly liaises with designers, asset owners, contractors, helping them to achieve the most optimal solution using geosynthetics on projects and has a special interest in numerical modelling techniques and how they can be utilised for characterising the benefit of geosynthetics in civil engineering projects. Please welcome Abid Ali.
Thanks, Amanda, for the introduction. And I would also like to thank John Lee for sharing his experience with us. I would like to thank all the attendees for being present for this webinar. My name is Abid Ali, and I work as a Senior Applications Engineer Geotechnics with Geofabrics Australasia. And today I will be talking about how geosynthetics can be used in payments built on expansive subgrid. The outline of today's presentation is as follows. First, I'll talk briefly about the problem of expansive subgrade and why it is a problem when it comes to payments, and also how the expansive potential is generally quantified. The recommendations given in all sorts for dealing with expansive subgrade, what we can learn from the field trials carried out in the US, where geosynthetics were used to stabilize payments on expansive subgrid, a numerical study undertaken to understand the benefit of mechanical stabilization for payments on expansive subgrid, and geosynthetics which can be used for payments on expansive subgrid. In conclusion, all right, so what is an expansive soil? An expansive soil is a soil that swells on wetting and shrinks on drying. So why is it a problem when we construct payments on it? In payments, generally, most of the moisture changes tend to occur towards the edges and less towards the center line. This gives rise to a differential volumetric change across the width of the pavement. So when the subgrade swells on wetting, there's more swelling towards the edge and less towards the center line. Similarly, when the subgrade shrinks during dry season, there's more shrinkage towards the outer side and less on the inner side. And this gives rise to differential movements across the pavement. Now, when the pavement is subjected to repeated cycles of wetting and drying, this can impose significant stresses on the pavement and cause it to crack longitudinally, as we can see in this figure. The damage caused due to expansive soil is estimated to be between 9 to 15 billion US dollars in US alone, and half of that comes from damages to payments on expansive subgrade. In South Australia, the damage is valued at $1.46 billion for houses constructed before 1981, and it results in $20 million per year for water main breakages and $60 per square meter for pavement repairs for a local city council in Adelaide. All right, let's look at how the expansive potential of a reactive soil is generally quantified. In Australia, we generally tend to use the Australian standard AS 2870 2011 for determining the characteristic surface movement YS. So this characteristic surface movement YS is a measure of the reactive movement of the site, and then this is used in design of residential slabs and footings. The Osterholz method for classifying reactive subgrade is shown on the slide, and TMR's modification to this is also shown. The reason why I have highlighted the CBR swell is because the CBR swell reference um, over plastics for active subgrade for a payment. All right, let's look at the approach given in Osroads for dealing with expansive subgrade. If you look at the Osroads Guide Part 2, a number of recommendations are given in clause 5.3.5 dealing with expansive subgrades, but there is no mention of geosynthetics. A common practice is to use a minimum amount of cover material of low reactive or of low reactivity, or this approach is called the cover method. The cover requirements vary from state to state, and where specific geotechnical assessment is required, AS2870 approach is generally adopted to determine the cover required to limit the differential heave to an acceptable limit. The cover thickness depends on several factors such as the depth of suction change, HS, the crack depth, presence of any bedrock or water table, the shrink swell index used to determine the characteristic surface moment YS, the acceptable differential moment, as well as the design traffic. For motorways, 20 millimeters is generally considered as an acceptable differential moment. Now let's look at few terms or mechanisms which are quite important to understand when it comes to pavement geosynthetics in expansive subgrade. When we talk about pavement geosynthetics, the term reinforcement is quite commonly used. From a pavement perspective, this would mean that a geosynthetic is anchored at two ends, and when a vertical load is applied, it undergoes deformation and mobilizes a tensile response or provides some sort of a benefit. So for reinforcement, there are two things to note. One is that tensile strength is important, and second, deformation is required to provide any benefit. Now, it is also important to understand the concept of stabilization, which is totally different to reinforcement. The definition given by ISO is given over here, but there are two things to be noted when it comes to stabilization. The tensile strength is not important for stabilization to take place. Rather, the soil geosynthetic properties are important, and the geosynthetic interacts with the soil and it improves the properties of the soil, and therefore deformation is not required within the geosynthetic, in contrast to reinforcement. So in today's presentation, we will see how geosynthetics can help pavement on an expansive subgrade by way of mechanical stabilization, and another function, that is by reducing the moisture differential across the pavement. I like to present few case studies from this paper where the pavement performance was reviewed from a mechanical stabilization perspective. So in the field trials that are reported in the paper, 5 sites were monitored in Texas, USA, and a variety of geosynthetics were used. So biaxial geogrids, multi-axial geogrids, polypropylene geosynthetics. All case studies were located between a TMI of -20 to a TMI of +20. That means a suction depth ranging between 3 to a meter and a half. The pavements were generally uncurbed, round at center line, and sloping to the sides with V-shaped ditches on either end of the road. It's important to note that each test section within a case study had the same environmental conditions and vegetation. The pavement performance for each test section was quantified in terms of a parameter called longitudinal crack index, among other parameters. So let's look at the first case study, which is FM1774. So the average the average annual daily traffic at the time of construction was 1100. The PVR for site B1 varied between 30 to 65 millimeters, and for site B2 varied between 30 to 45 millimeters. PVR, or potential vertical rise, is a measure of the reactive moment of a site, and this approach is generally adopted in the US. So section B1 was where a polypropylene biaxial extruded geogrid was used, and in section B2, a polypropylene biaxial laser bonded geogrid was used. Both the geogrids met the Texas DOT spec for geogrids. It must be noted that the tensile strength of GS2 was greater than the tensile strength of GS1. But if you look at the field performance, section B1 actually fared significantly better than section B2. This leads to the understanding that higher tensile strength doesn't necessarily relate to a better field performance. Let's look at the next case study, which is from State Highway 20. In this case study, 5 sections were analyzed. The average annual daily traffic at the time of construction was 5,300. No PVI information was available for this case study. The liquid limit varied between 40 to 58, and the PI between 26 to 41. The subgrade was classified as a highly plastic subgrade. Out of the 5 sections, biaxial geogrids were used in 2 sections, section D1 and D2. In the remaining 3 sections, multi-axial geogrids were used. Again, it must be noted that the pavement thickness is same in all the sections. What is noted based on monitoring of field performance is that multi-axial geogrids resulted in a better pavement performance compared to the biaxial geogrids. So what do we learn from the US experience? From case study B, we learned that higher tensile strength does not necessarily relate to a better field performance. Rather, it is important to understand the geosynthetic soil composite properties. And from case study B, we learned that multi-axial geogrids performed better than biaxial geogrids. Further study was undertaken at University of Texas at Austin to understand one single parameter that correlates well with the field performance. The critical property was identified as the stiffness of the soil geosynthetic composite under small displacements, or it is called as KSGC. Now, based on the lab testing carried out to determine KSGC and based on the field performance, it was noted that multi-axial geogrids had the highest KSGC and they resulted in excellent field performance. The geosynthetic benefit in US was characterized by the longitudinal crack index. Now let's look at a problem where the reactive moment of a site is 80 millimeters, the depth of suction change is 2.5 meters, and the crack depth is half the suction depth. As per AS2870, to limit the differential heave to 20 millimeters, we would require a cover greater than 1 meter. So in this study, we are trying to quantify the geosynthetic benefit in reducing the differential heave and if the required cover can be reduced by adopting geosynthetics. So in this approach, the characteristic surface moment Ys was calculated using AS2870 and it was numerically simulated using Plaxis 2D by the volumetric strain option. As can be seen in the figure on the right, a very good agreement can be observed between the heaves predicted as per AS2870 and that obtained from Praxis. So we undertook a parametric study where three different pavement thicknesses were analyzed. The pavement width was 10 meters and we only modeled half the pavement width. Non-stabilized pavement or a pavement without the geogrid was modeled using more column parameters shown, and a mechanically stabilized pavement was modeled using a special constitutive soil model called as TSSM. The PSG of the material for which the TSSM parameters were adopted is shown over here as well. The elastic stiffnesses for both the pavement types were kept the same. In order to quantify the benefit of mechanical stabilization using multi-axial geogrids, large triaxial compression testing is required. So this is not the regular sized triaxial sample. It is a large triaxial one where the diameter is half a meter and the sample height is 1 meter. And tests are carried out with and without the geogrid. When the geogrid is used, it is placed at the mid height of the sample. Based on the large triaxial testing, what is noted is that when the geogrid is placed in the sample, there is an increase in shear strength and the sample exhibits greater ductility, that is, it fails at larger strains. Now, this behavior is incorporated into the tensile stabilized soil model. The strength envelope shown in red is applicable to the location of the geogrid, whereas the strength envelope shown in black is applicable to the areas outside of the zone of influence of the geogrid. And the difference between the two is the mechanical stabilization benefit. For those who are interested in knowing more about TSSM, they can refer to this publication. Let's look at the results from the study. The heave at the pavement center line for the non-stabilized pavement is 66 millimeters, which is quite close to the value obtained from AS2870. The differential heave for a non-stabilized pavement is 29 millimeters, again, which is slightly lower than what we get from AS2870. But if you look at the differential heave of the mechanically stabilized pavement, it is only 10 millimeters and much lower than the 20 millimeter acceptable limit. So from this, we can see that mechanical stabilization helps reduce differential heave. If you look at the results of the 500 millimeter thick pavement, the total heave at the pavement center line is the same for both mechanically stabilized and non-stabilized pavements. The differential heave for the non-stabilized pavement is in good agreement with what we get from AS2870, but the differential heave of a mechanically stabilized pavement is significantly reduced. In this video, we will see that when a non-stabilized pavement is subjected to heaving, large strains are induced in the pavement. Naturally, the pavement is more susceptible to longitudinal cracking. On the other hand, when a mechanically stabilized pavement is subjected to heaving, significantly lower strains are induced in it, and therefore the pavement is less likely to develop longitudinal cracks. If you look at the results of the 1 meter thick pavement, the total heave for both the mechanically stabilized and non-stabilized pavements are quite similar and in close agreement with the values obtained from AS2870. But the differential heave for the non-stabilized pavement is quite high compared to what we get from AS2870. The interesting thing is that the differential heave from the mechanically stabilized pavement is only 14 millimeters, which is again lower than the 20 millimeter acceptable limit. If we plot the normalized differential heave on y-axis and the pavement thickness on x-axis, we can see that for all the pavement thicknesses analyzed, mechanical stabilization can reduce differential heave by more than 50% for the same thickness when we compare it to a non-stabilized pavement. So let's look at some geosynthetics for expansive subgrade. This is the first generation multi-axial geogrid, also called as triaxial geogrid because it has triaxial apertures, and this is what was used in the US field trials. And John Lee also mentioned about these geogrids. Then we have the next generation multi-axial geogrids, which is a co-extruded and a multi-aperture multi-axial geogrid. These geogrids were used in the numerical study that I just presented. Then we have geocells, which can also be used for mechanical stabilization. And lastly, an interesting product called the enhanced lateral drainage geosynthetic, which we will see in the next slide. So, what is an enhanced lateral drainage geosynthetic? It is a special type of woven geotextile that, in addition to providing reinforcement, stabilization, separation, and filtration, also provides an additional function of moisture management or enhanced lateral drainage. And that is possible by use of special wicking yarns that are hydrophilic and hygroscopic. An ELDG allows for moisture migration under unsaturated conditions. The intent of using ELDG in a pavement on an expansive subgrade is to achieve more uniform distribution in moisture content across the pavement, and by doing that, the differential heave will also be reduced. Now, this has been verified by field trials carried out on State Highway 21, and this statement summarizes the key findings of that research. In summary, the ELDG is able to prevent cracking in the shoulder by equilibrating moisture beneath the geotextile through enhanced lateral drainage. So that brings me towards the end of my presentation, and I would like to conclude with the following points. Based on the research carried out in US, high tensile strength does not necessarily correlate to a better field performance. Rather, it's the soil geosynthetic composite properties that should be considered. And multi-axial geogrids had the best soil geosynthetic composite properties, or I should say the highest KSGC values, and they resulted in the best performance in the field. Now, based on the numerical study that we carried out, it can be said that mechanical stabilization using stiff co-extruded multi-aperture multi-axial geogrids could help reduce differential heave by 50%, and therefore it may potentially overcome the need to further thicken the pavement to achieve acceptable differential heave of 20 millimeters. We have undertaken further work to evaluate the influence of different parameters on the numerical results. Lastly, enhanced lateral drainage is an attractive option on expansive subgrade to homogenize the moisture content across the pavement width and therefore reduce the potential for differential heaving. So that's it from my end, and these are the references for today's presentation. I would like to thank you all for your attention, and I look forward to the question. Thank you.
Thank you, thank you. It's now your turn to get involved. Please ask our speakers questions via the YouTube chat box and who your question is directed to. Also, a big thank you to everyone who submitted questions whilst registering for this webinar. We might start with you, John, followed by Abid. That we've had a question that's coming from Brendan, and Brendan is watching from New South Wales. Good afternoon to you, Brendan. And starting with you, John, Brendan is asking, we have a project with a recurring groundwater issue whereby groundwater is seeping vertically through compacted clay and pavement layers. Other than subsurface drainage, what would be a possible long-term treatment option, John?
Thank you, Amanda, and thank you, Brandon, as well. Say for my answer, I'll need your help later on as well. But for my part, what I will help Brandon, I'll say, will be an integrated solution as well for our approach, and for what information you provided. I would say subsurface drainage is needed as well, because like in my presentations mentioning, the key is we need to make sure all the waters between the pavement levels to be proper discharge as well. And also with the pavement layers, not even the subgrade as well, we need to think of a appropriate pavement material as well. I know there's like if we can, because it's not like every single time we're asking for Rolls Royce. So we do once again we do a fit to perfect design. Say for example, would be better to do a composite pavement asphalt with moisture insensitive subbase, which is for example HPB or with cement content as well. So and for this case, I would like to, if you don't mind, probably we'll have a chance to talk offline as well. And right now, for a bit, what was your idea as well for the situations?
Thank you for that. Arbit, do you want to comment on that question from Brendan?
Sure. Thanks, Amanda, and thanks for your input, John. If I understand the question correctly, we could potentially use the ELDG area if there's a capillary, if there's a rise in the groundwater table, or there's a capillary barrier effect, or if there's infiltration into the pavement. So the ELDG can potentially help wick the moisture out of the pavement to the sides. So that's all from my end. Hope that answers the question. Thank you.
Thank you, Arbit. And just staying with you for a moment, that we've had a question coming from Murray, who's watching from Queensland, asking you, Arbit, what is the location of the clickbait photo? Would a flat percentage crossfall subgrade assist in reducing tension forces in pavements over highly expansive subgrades? Arbit.
Thanks for asking the question, Murray. I'm not too sure about the exact location of the photo, but coming to the question of 0% crossfall, if you look at the case studies from the US, they did have a certain crossfall within the pavement, and the geogrids did assist them in reducing the heave within the pavement. So my answer would be to implement geosynthetics within the payment and leave the crossfall as it is. Thank you.
Thank you for that. And staying in Queensland, a question for both of you again, starting with John, and it's coming from Lucas. And Lucas is asking a great question, asking you, John, and then Arbid, how do you deal with local authorities that do not like geogrids in pavements due to operational concerns of the grid being cut by service authorities or others that may not be aware there is a geogrid? John, your thoughts?
Okay, thanks, Amanda, and thank you, Lewis, as well. So for the case of this situation, yes, like if it's for the local authorities, the key is like my presentation as well. Depends on the locations for the geogrid and how we do that profile as well. Because like with for example, for my understanding for these situations, would be like with a services might not be able to have the 600 depth as well. So the case is like normally what Lucas up for my understanding as well, we've probably say that, say for example, with other utilities, they might come with a cover like the orange cover also. But for our case in here, the first thing is we need to make sure we are having the sufficient depth to design that profile as well. Because the key is like like my presentation as well, we do cover on top of the services and stuff. And this is about the operations and the delivery. And this is the key as well, because I understand for Brownfield is always being jammed, but it's still there are some lines and approach we need to keep the combinations of each of the layers. And as in the pavement perspective as well, we can design a pavements might not be all granular as well. We can do it in the pavement layers to see whether or not we can strengthen the say the asphalt layers and or the simultaneous subbase as well. So will be once again is an integrated approach. Yep. So to you, Albert. Yep.
Thanks, John.
Arvid.
Yep.
Yeah. The simple answer that I have is we've got certain guidelines around reinstating geogrids for surface trenching. So you can get in touch with us, and we can provide you with the guidelines for reinstating the geogrids. So that should not be an issue.
Thank you, Arvid. Thank you for that. And just staying with you for now and moving down the country to New South Wales, we've got a question that's coming from Mohammed asking you, Arvid, what is the range of total cost of geosynthetic material per unit, metre square area? Thanks, Arvid.
Thanks for the question, Mohammed. This is a very complicated question to answer. It depends on the type of geosynthetic, as I have shown a few different types in my presentation. So you just have to get in touch with us, and we can provide you some indicative price. Thank you.
Thank you for that. Keeping moving south, we've got a question coming from Ming. Good afternoon to you watching from Victoria. Asking both of you, starting with you, John, really interesting question about, has there been a successful case where treatment of expansive subgrade with geosynthetics being approved by state road authorities on major arterials? John, starting with you.
Thank you, Amanda, and thank you, Ming, as well. First thing first, the first questions, our first answer to you is yes, and like it's not just in Victoria's, in all interstate as well, and for Victoria's, for my colleagues from our pavement teams, they will give you more updates as well. But allow me to speak on New South Wales, Transport New South Wales, and for example, Western Sydney area, the new airport, and those area, because those ground conditions are soft, and Geo Creek is one of the major helps for us to treat it with the soft subgrade. Yes. And off to you, Albert. Yep.
Yeah, Abid, what's your view with the state road authorities?
I think John's probably answered that question quite well, so I think I don't have any input on that one.
Well done.
But I think, sorry, if you look at the US case studies, one thing which I probably didn't mention in my presentation was the paper which I showed by Professor Zornberg. It clearly mentions that Texas DOT is one of the states procuring the largest amount of geogrids in terms of, as a transportation agency. And the primary reason is basically to deal with expansive subgrade and not for reduction pavement thickness for traffic loads. So I hope that gives some context.
Yeah, that's great. Thank you for that. Thank you to both of you. Just staying in Victoria and staying with you, Arvid, we've got a question that's coming from Nikita asking, how do geosynthetics compare to traditional stabilisation methods performance-wise and cost-wise? Thank you to Nikita for that.
Thanks, Amanda, and thanks, Nikita, for the question. Again, I'll go back to that paper from Professor Zonberg, where he's also analyzed test sections where no geogrid was used, but lime stabilization was used within the subbase as well as the subgrade. And Professor Zornberg, he basically advises against that because he thinks that it basically creates a brittle crust and it sort of exacerbates the problem. So his recommendation is to use geosynthetics, and it's probably much more easier to install geosynthetics rather than stable undertaking chemical stabilization, as you don't have to worry about the weather conditions. So I hope that answers the question. Thank you.
Thank you, Abid. And we have a question, John, that's come in from Kieran, and I think we have touched on it as well a little bit earlier, but Kieran's asking, for the local council pavement designs with stabilisation, how did you deal with services? Were there many conflicts? Great question. John.
Well, thanks again. And for that questions, like what I say previously as well, the most important part I probably answer this way is communication, communication, and communications. The reason I'm saying that is apart from the state or rural authorities, if it's for council or private developers, they might have like a question and say that, oh, is it being approved? What's the AS and how to do? Because like in the state road authorities in like with the council or private developers, for private developers also they're on the OSPAC, which is slightly not the same as in what we do in state road projects. So how is the arrangements for that utilities, where to put those geogric and like a bit just then we mentioned about what they mainly were about was when they cut it, they were about, oh, can we do the lappings again, how to sort of like we retrofit that as well. So the key is we will do a tailor-made design to make sure even with the chances or say or with the road opening, how is that backfill also. The first thing is not passing back the ball. We need to understand situations more because we just can't answer on a high level questions as such. Then in return, I would love to work hand in hand together with practical solutions. With okay, yep, that's my answer.
Thank you, John, for that. Thank you. Navid, we've had a question come in from Andre, watching from New South Wales. Good afternoon. Asking Navid, which geogrid is more suitable as a reinforcement control of deformations for expansive subgrades, biaxial or triaxial, and why? Navid.
Thanks, Amanda. Thanks, Andre, for the interesting question. And I think I've probably answered this during the course of my webinar, where I clearly stated that multi-axial geogrids, they perform better in the field compared to biaxial geogrids, and that's primarily because of the ability to interact with the aggregates. So based on the testing carried out at University of Texas at Austin, they noted that the soil geosynthetic composite stiffness, or KSGC, is highest for triaxial geogrids. So my recommendation would be to go with multi-axial geogrids. Thank you.
Thank you for that, Abid. We've had a great question that's been directed to both of you, starting with you, John, that's come in from Callum. Callum's in Victoria, asking John, Abid, in terms of how to best determine if an expansive subgrade is present, is this something geotechnical engineers, contractors routinely look for during the design phase ground investigations? Or does this need to be clearly specified as a requirement? If the latter, what specific requirements would you recommend specifying so that the design is suitably informed? John.
Okay, thank you, Amanda. And I love these questions because for this case, the key is we really need to start with the formation of the projects, like what I mentioned in my presentation as well. For projects, our focus is whole of life, and this is actually the first step of that whole of life as well in the formations. Because, like, I understand there are a lot of moving part and uncertainty as well, but for that area, when as a designer, pavement designer comes in, I need to understand the conditions, the ground conditions, project requirements are what I'm going to deliver as well, and ground investigation is one of the key part or in the beginning. So where to put the borehole at what uh, of the depth to do the lab tests and do those. Again, like in one of my slides as well, because I understand this question has come from Victoria. I use that transport supplements to Oslo, which is the guide of say CBR2 and swell 2.5%. So those are very important information to start with, and I'm sure Fricro is having a very similar requirement as well on this aspect. So, which is start with the planning, and the next stage, yes, when the uncertainty happen as well, we it's based on Code of Ethics as well. We need to make our stand to voice out to the clients and the stakeholder as well to say that is yes, we might find ourselves soon. There are expensive subgrades on site as well. Then the next thing is we need to deal with it, just like design updates and make sure we develop a design which is suitable for the situations. We can't just come in and say that, oh, I do ground regulations 2-3 years ago. Situation might be the same, and we really need to, as I say as well, that SAFIRP, we need to do that fit to purpose design to make sure our deliverables last for that design years with that loadings. Yeah, and this is my part, and off to you, Abbott.
Abid, do you want to talk about specific requirements for recommending specifying? Do you want to add to John's comments?
I think John has probably addressed that question in quite a bit of detail. The only thing I'll mention is an early indicator of whether soil is expansive or not could probably come from the CBR test. So guidelines are given in the Oslo's manual, as well as for those who are based in Queensland, to classify the subgrade based on the CBR swell. So that could be used as a good check for determining the reactivity of the subgrade. That's all from my side. Thank you.
Thank you. Thanks, Abid. We've had a question, John, that's coming from Rintu asking you, why is there a need for a second layer of geogrid?
Okay, thanks for that. And the situations are just like what Albert just said as well. It depends on the situations also, because like we think about this way, the ground conditions is not a homogeneous. Like whatever, every single times we come with it, we started with an area. They are as well. Say for example, based on what I did in talk about say 15, 16 years ago, I have a port in QA with a soft ground talking about like CBR 1.5 as well. And we tried the situation to say that one layer doing some of the stabilized material as well. But the thing is still not getting the result we want because like as I mentioned, is a port, the loading is high as well. So we need to have a combinations to make sure the second layer comes in, and in between the 300s, we do a stabilized material. And in fact, actually, it's just like what me and Albert first started with as well. He gave me a good help in private development projects with 2 layer of geogrid and having the cement stabilized in between as well. So this is the things is based on the situations and based on not just the ground, on the end side, what we need to deliver. Say for example, we need to deliver a row for 40 years with 10 million axle load. So it's a combination to say that this is the high demand they need, and now we need the 2 layers or so. So it's not like everyone come with one layer also, but still one thing as well. We don't do a proof roll after we put the geogrid. We'll put the geogrid. Yep.
you for that. Abid, bringing you back in, we've had a question from Vismay asking, what is the minimum thickness of gravel allowed on a geogrid? Abid.
Thanks, Vismay. The recommendation is if you're using a multi-axial geogrid, to have a minimum cover of 150 millimeters of gravel material. So I hope that answers the question. Thank you.
And Vismay actually had another question as well, Abid, asking you if the layer on the combi grid installed on top of the subgrade, at what maximum depth is another layer of the grid to be repeated to achieve the best outcome?
Thanks again, Vismay. Generally, the spacing would vary roughly between 300 400 millimeters. 400 millimeters is the absolute maximum for multi-axial geogrids. But again, this is a general recommendation, and it would vary from project to project. Thank you.
Thank you, Abid. Abid, we've had a question from Joro that's just come in asking you, can the Georgia Triad or the woven Georgia textile be used under road embankment to reduce settlement? Thank you, Joro, for that. Abid.
The triaxial geogrid can be used for minimizing differential settlement, but probably not the settlement from the dead loads. And the specific application in this webinar is to reduce the differential moment due to reactive subgrade. So the topic of my presentation is not much towards the road embankment. I hope this answers the question. Thank you.
Thank you, Abid. And just staying with you, we've had a bit of a flurry. We've got a question from Julius asking you, Abid, is the finite element modelled in 3D? If not, how can it be correlated to the triaxial testing? Abid.
Thank you, Julius. A very good question. The finite element modeling was undertaken in 2D, and the triaxial testing was primarily undertaken to determine the parameters or the effect of stabilization on the aggregate. So the results of triaxial testing are generally implemented into a user-defined soil model called TSSM, and that has been used for working platforms as well, and it has been verified with field testing. So all good on that front. I hope this answers the question. Thank you.
Yeah, thank you. It does. It does. John, a question we've received from Rintu. We asked two questions. One that we did answer previously. Why is there a need for the second layer of GeoGrid? But Rintu goes on to ask, John, are there any benefits of combining different types of GeoGrid in two-layer design?
Thanks, Amanda. Thanks for the question as well. So for the first part of the questions, probably I will refer back to the last one as well. It depends on situation as well. So for the second part of the questions, the next layer, the second layer of the GeoGrid is needed for if it's really soft for the ground, and the next thing is depends on the traffic loading as well. So like what I give the samples in QA, and also like just then what Abbott helped me in our first projects together. Those are the one which is needed, and it definitely strengthens the subgrade and helping out the pavement profile as well, because once again, the key point is for all the second layer comes in also, it's not about we need to do less of the excavations. The key is we need to think about, I would say in my wordings, respond to the ground situations. And for that ground situations is needed for that combinations of approach, and which is in my one is a solutions, two layer the stabilized materials as well. Yep. This is the approach when it's needed. It's not like, oh, well, we goes in. This is we goes in with this option or so. Whenever we need to study the situations, maybe high design traffic loadings and also the ground situations again is really soft. Yep, that's my answer.
Thank you for that. Okay, Abid, we have had a question come in asking you how much does the angularity of the gravel factor matter when it comes to EDLG and traffic loading? Abid?
A good question. So the ADLG is not only, it is a woven geotextile, and it can handle some amount of installation damage. I don't have an exact answer for this at this stage, but you can reach out to me, and we can investigate and come back. And as far as traffic loading is concerned, so it has been used on a number of projects as an primary for enhanced lateral drainage, and yeah, it does provide mechanical stabilization benefit as well, primarily through interface friction. So I hope this answers the question. Thank you.
Thank you, Abid. And just staying with you for now, we've had a great question that's come in from Editha. Good afternoon to you, Editha, asking you, Abid. Culverts are heaving and pushing out the pavement surface, making road conditions very dangerous. We call them black soil. How do we prevent this occurrence? Abid.
Um, Thank you, Edita. One of the ways possibly could be to construct pavements using geosynthetics to minimize any differential moment, and also possibly using geosynthetics under the culvert slab to reduce the effects of differential heaving under the culvert. I have not investigated the use of geosynthetics under culvert slab, so this is something which would require further investigation. But so far, my research has primarily been based on use of geosynthetics for reducing differential height within payments. So I hope that answers the question. Thank you.
Thank you.
If you don't mind, probably I add in two points to help out a bit as well. So for these questions, what I add in is like first thing is we need to carry the mind of the risk control, the 6 degrees, the 6 degree hierarchy as well. Because like yes, it's important for us we can put in the geogrid comes in and help, but also with us for the backsoil also we need to thinking of whether or not how we treat it might be like to what level we're going to get some of them out of the site as well. So this is some things like we need to consider also for point one. And the second point is once again for the situation like this, because if it's backsoil also, we really need to think of if it's too high for the loading and stuff. It's not just on the sub base or the geogrid level. What kind of other pavement type we should do as well? Because like we do have pavement options to help out. Might be once again I would say or should be a composite asphalt or high modulus asphalt with like simultaneous material. So is a integrated solutions and just those saying that we'll keep the backsaw and with a geogrid comes in then because it's solutions we need to be think through getting all the help from multidiscipline as well to make sure that solution is the best fit to purpose. Yep, thanks for that.
Thanks, Sean.
Thank you. Thank you for that. And Abid, we have had a question from Stephen. Good afternoon, Stephen, asking you how much compaction of the gravel is required to ensure successful use of the geogrid as a reinforcement over expansive soil? Abid.
Well, the general recommendation, I'm not talking about expansive, but the general recommendation for compaction is basically to project specification. So that's all I'll have to say. Just compact the soil to the project specification for example, from the case studies in the US, I don't have any information about any special compaction requirement. Maybe John can comment over here from his experience. Thank you.
For the part is yes, thanks Albert, and especially this same as you as well, because like say for my side from New South Wales, the first things I'll come to you will definitely say that depends on what our workforce say as well, which is like for the competition degrees and like 98% also. So this is my first rules of thumb as well, and if the material is like can't reaching up to there, we need to find a way to stabilize. Maybe once again, like my last question, the last comment as well, we really need to consider how we're going to take it out as well. Yeah, and which is same as yours. We need to fulfill with that my case stable authorities requirements as well. Yep.
Thank you for that. Thank you for jumping in, John. And, today we've talked about expensive subgrade problems and remediation. And maybe starting with you, John, what do you think are the major trends that are coming? Obviously, Engineers Australia, we have our Climate Smart Engineering Conference coming up at the end of November. What do you see are the key trends in this field going forward?
Oh, for that part, I'll probably do the sharing first. I do read some paper as in the helping out in the judging part as well. Those are very interesting papers and the abstract. And thanks, Annual Australia, to give me the opportunities to help out in that part also. And for this one is like, you should see my presentation for the first the cover as well. There's a huge impact nowadays for the heavy rainfall and what the climax is affecting our environments and our construction industry as well. So, which is like we need to have for my part as a designer, we need to update ourselves to make sure our deliverables are up to date, fitting in the current situation as well. Because think about it this way, I'm in this business for up to my third decades already. I can't use whatever I did like 3 decades ago to say that this is the things I did now. I need to do my adjustment and fine tune to make sure if it's with this rainfall with situations what we can do together. And that's the reason like for me always call up a bit very often as well and like to geotech to structures to drainage utilities I that's my position to work hand in hand. Yep.
Fantastic. Thank you for that. And Abid, what do you see as future trends, opportunities, challenges?
Yeah, especially from the expansive subgrade point of view, I think one of the key challenges is the possible change in suction depths with change in climate change, with change in climate. So that's probably something that needs to be investigated, and either the problem could worsen or it could even out. So use of geosynthetics can help in some way, but I like John's approach of working hand in hand for coming up with a great solution. So that's all from my side.
Thank you, and thank you. And as we're getting towards the end, I would just like, we've covered a lot today, probably another webinar's worth, but I'd just like, starting with you, John, just to sort of take a minute or so just for the five key takeouts you want to leave our audience with today. John.
5 key tickets or the probably I'll use my last slide then. The first thing is in our design or deliverables have had to be that SAFIRP because like for the material, the geogrid alone is not going to be like a magic bullet. We need to understand it at both sides, the material, the defines, and also our ground situations, project requirements, what we are going to deliver as well. And the next thing is for my situation, it's not just a design. I need to make sure the design is constructible, less activities in maintenance, and safety as well, because like I need to think of the maintenance crew comes in the highway. Is it very hard to get access in also? So it's once again, it's a whole of life. Make sure like for the material comes in, everything is practical and constructible. That's my statement would say. Yep.
Thank you. And Barbit, what would you like to leave the audience, just to summarise the key points of what you presented today?
Well, geosynthetics can have the potential to reduce the maintenance requirement for payments built on expansive subgrade, provided the payments are designed properly, as John said from his experience. Yeah, so that's all from my side. Thank you.
Thank you. Thank you. And what a great session. It is all the time we have for today. So please join me once again in thanking John Lee and Arvid Ali for their time and input. I'd also like to warmly thank Engineers Australia's industry partner, GeoFabrics, for their ongoing support. As always, please take a couple of minutes to complete a short feedback form, which is linked in the description box below. It helps us improve and plan for future sessions. On behalf of Engineers Australia, thank you again for joining us, and I look forward to seeing you at our next Thought Leaders event. Thank you and good afternoon.